Hi, we are Team Copper's Cove, and my name is Sydney Gardenhire.
My name is Iliana Aguilar.
My name is Deepansh Bhatia.
And my name is Andrew Silva.
So, our introduction of who we are as a team, it begins with our PhD student Brendan, who has worked with Copper's Cove and has previous knowledge of traffic problems. He has prepared a report talking about crash incidents at some important intersections, and also has vast experience with spatial data and GIS data. Myself and Andrew are urban planning majors who also have experience in GIS data, and our goal was to help to provide the solutions to the city through that data. Illy and Deep have experience with computer science, and that has helped them to develop the AI scripts for the city of Copper's Cove.
When we met with the city officials of Copperas Cove, they presented a traffic congestion problem that they were hoping we could step in and alleviate. They said that the population had been steadily increasing over the past few years, and it had led to traffic congestion. They were afraid it would only get worse if they didn't try to do something now to prevent it. So that's the problem that we were presented with, and that we were working a solution towards. Next slide, please. Since we wanted to really take advantage of the different skills in our team, we leaned towards finding a solution using AI and machine learning, urban planning, and as well as GIS data from previous research conducted by Brendan, who had been working closely with Copperas Cove prior to the semester. Since the data we were provided with was very limited, we also wanted to make sure we laid some groundwork in that area so Copperas Cove could easily collect traffic data in the future for their city. We also plan on making modification suggestions through planning and streetscape design, as well as an extensive research on traffic congestion solutions. After running preliminary analysis on the traffic and population data we were provided with, we realized it did not draw significant or meaningful results. We tried to contact TexasDOT to request more data if there was any more available, but they did not have the additional data than the one they had already provided on their website. We decided on a different approach that would still allow us to use AI and machine learning to provide the city with innovative solutions to traffic congestion. We decided on using computer vision to help Copperas Cove gather data, and that way future teams can build sophisticated AI models using the traffic data gathered with our script.
So as Ellie went over it already, we plan to use a script that utilizes computer vision to count the number of vehicles passing by a camera installed at an arterial or maybe a highway or maybe an intersection. And then the script should be able to export that data to a CSV file, which can be further used to upload it to a database so that the city can accumulate traffic data for future use. And that future use includes training for their AI models. So we plan to use the technique of frame differencing, which is a form of unsupervised AI. And there are some basic steps that we are utilizing in our AI script and for the technique of frame differencing and computer vision. So first it takes a video as an input, and then it divides that video into its individual frames. And then it picks pairs of frames and finds the difference between the two. If the camera that is watching the road, only the vehicles will be moving, will come appear in the difference, and then we'll be able to single out the vehicles on the road through this frame differencing technique. We amplify those differences using dilation and thresholding, and then after that, using computer vision, we draw bounded rectangles around each vehicle, and then we count those number of vehicles passing through a certain line that we draw arbitrarily through the video. Next slide, please. So there are two basic advantages to this script. The first is that it is flexible because you can just use it for virtually any video, traffic video. And it is also incredibly easy to use with powerful results. You just enter the name of the video and then you'll get a CSV output which will contain the duration of the video and the number of vehicles it counted during that duration. However, since this is still a rudimentary script, there is no UI yet as of creating this presentation. If time permits, I and Ili will plan to add a UI for the app, which will make it accessible to everyone. But right now you have to input the data through the terminal, which not everyone may be able to do that. The script also only works for particular angles, that is stabilized video recording of vehicles from the top, and it does not work with other angles like such as the side of a road or from the bottom of the road. And the usage of the script also requires some technical knowledge, such as some math skills and some very basic understanding of contours, because you will be providing the line where you want to draw the vehicles and also the bounds of them. And the user has to provide all of these themselves, so they need some knowledge. Next slide, please.
All right, so to introduce one of our case studies that we had researched, we felt that it was a different approach to provide to the city, and it was one-way traffic reconfiguration. This study took place in 2 different cities, the first being Sioux Falls, which is a medium-sized one-way traffic system, and then in Isfahan, Iran, which is a real-world large-scale transportation network. The goal of this study was to test the efficiency of one-way traffic system frameworks. So the situation at hand throughout the case study is that traffic congestion is inflicting immense cost on cities along with the quality of life in urban areas. And this case study explored different possibilities in implementing one-way traffic systems to create a sustainable traffic model for cities. And the significance that this has to Copperas Cove is that they are continuously growing, according to the city officials, and this article emphasizes on traffic management. The feasibility of this research is if the city is able to configure the city of Copperas Cove, if they are able to configure the total travel time within the city, along with the total travel time in a specific congested area, that would lead to a one-way traffic system being a possible option and a solution for the city. And the result of these 2 case studies were that one-way traffic model being a more efficient and less expensive route to take when reconfiguring these traffic congestion issues.
So when thinking of the micro scale of this project, key drawbacks to avoid is planning without planning. And what that means is major market failure in a smaller municipality is detrimental to growth and can hinder marketability. So streets like North Main Street are vital regions to develop, not only in transportation ways, but in the quality of life for the citizens. Through research and analysis, solutions through these have already been solved. They just need to be prioritized. Project North Main Street represents all current trends of smart planning and low congestion of automobiles. I think if Copperas Cove is able to combine multi-use pathways and L2U forms of streets, they can shape an identity that can not only be shown across the United States, but across Texas.
So to kind of finally conclude and pass the torch to the future, through the efforts of Team Copperas Cove, the city now has the ability to collect their traffic data and plan for future traffic increase. This project provided key resources in not only transportation, but the development of the municipality. And thank you very much.